Hello everyone, I'm Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on single phase off wave controlled rectifier with RL load and RL with freewheeling diode load. Here the classification of rectifiers, single phase rectifier and three phase rectifier. In the single phase half wave rectifier and full wave rectifier. In the half wave, in the three phase also half wave and full wave. In the half wave rectifier again controlled rectifier and uncontrolled rectifier. In the last lecture we have completed. So first here single phase half wave controlled rectifier R and L load we completed. So today we are going to discuss about RL and RL with freewheeling diode. So this we will discuss today. So now here these are full wave rectifier. In the full wave rectifier, uncontrolled rectifier, controlled rectifier and semi-controlled rectifier. In the loads are R load, L load and RLE load. And next symmetrical, asymmetrical and full converter in the freewheeling diode. This is for symmetrical. In the half wave, in the three phase half wave, uncontrolled and controlled. In this controlled. So now here first single phase half wave controlled rectifier with RL load. So in the RL load what will happen? So first here we are giving the supply. The load is here R and L. This is R and this is the L. Resistor and inductor are connected in series. So previously we have studied pure resistive case and pure inductive case. So here resistor, pure inductive case, resistor case, pure inductive case and pure resistor and inductor case we are studying now. Now I am giving the supply to this SCR thyristor T1. So now here at alpha equals to now I am triggering from 0 to alpha. SCR is in forward blocking mode. So now I am triggering SCR gate at alpha. So now what will happen here? SCR is in forward conducting mode up to pi. Up to this pi means here this is output voltage. This is output voltage. Here output voltage up to pi. SCR is in forward conducting mode, but here up to pi it will be in forward conducting mode, but pi to this beta, this is beta. Phi to beta is also, this is for RL load up to pi only it will conduct, but here pi to beta, what will happen? Because of this inductor stores the energy in the form of electromagnetic field. So here from the it will stores the energy from 0 to pi. Inductor stores the energy and after that it will delivers from pi to beta. It acts as a current source and it will delivers the power from the load to source. So now here, so during this period, so now here this inductor will delivers the power to source, means this SCR will conduct up to pi to beta only. So now here alpha to pi, alpha to pi. So now here V0 is greater than 0, I0 is greater than 0 and power is greater than 0, means power is delivered from source to the load. So power is delivered from source to load. But here pi to beta, what will happen? So now here V0 is positive, V0 is negative. Here this is negative, V0 is negative And next I naught is positive and P naught is negative. So here power is delivered from load to source. Here I naught is positive and this one. So here why it is negative? It will follows the supply voltage up to pi is positive and pi to beta it is negative. So V naught is negative. So now here from alpha to pi this power is from power is delivered from source to the load, and here in case of pi to beta power is delivered from load to source. This is the case. Here this is the output voltage waveform. And what about the current waveform? Here current is up to this beta only. Here current is up to this beta. Now here this again this is second duration, and now subtract from this supply voltage output voltage. Vt equals to always Vs minus V naught. So this thyristor voltage equals to this, if you apply KVL, Vs minus Vt. Same, subtract from this waveform to this waveform, you will get this Vt. Add these two waveforms, you will get this. So add this one, and next here add this one, this equation, you will get same equation. And now here another thing is here, first this is actual waveform. Calculate the average value. How you will calculate the average value? V naught average equals to so V naught average means total time period. So this is the total time period. So up to here only. So total time period is 2 pi, and here it triggers at alpha, and up to beta it will conducting S here. So now here output average power area under the curve divided by total time period. So now here total time period is 2 pi and area alpha to beta, and it is following sine omega t. V equals to V, this equation is Vs equals to Vm sine omega t. Vm sine omega t dt. So now if you simplify this one, so now here 1 by 2 pi cos alpha minus Vm cos alpha minus cos beta. This is the V naught average. And now here what about the current equation? I naught equals to Vm by 2 pi by R. V naught average divided by R equals to cos alpha minus cos beta. So this is the current equation. And now here what about the RMS value of output voltage? So I naught RMS is this one, and here output voltage RMS. So these are average value. RMS value equals to 1 by 2 pi. So now integral of alpha to beta, and now here Vm sine omega t whole square d omega t. So now here if you simplify this one, 1 by 2 pi Vm square under root, and now here 1 minus cos 2 omega t by 2 whole square. So now here if you separate this one, here integral of alpha to beta. So now here Vm by 2 is common. So now here this is, if you simplify this one, 1 by pi beta minus alpha plus sine 2 alpha by 2 minus sine beta by 2 beta by 2. This is the RMS value of this output voltage of single phase half wave control rectifier with RL load. So now if you want the I naught RMS equals to, so V naught RMS divided by R. So now here first, second, third and fourth formulas related to this one. And now here conduction angle. So conduction angle means, so thyristor conduction angle is, so for what duration is thyristor is conducting. So now here thyristor is conducting up to what angle here. So now here, so here from alpha to pi, and that is for pure resistive load, but here it is conducting up to beta. So now here beta minus alpha is the thyristor conducting angle, that means conduction angle of SCR. And now here extension angle is the beta, up to this angle it is conducting, that is beta. And now here circuit turn of time. So circuit turn of time omega Tc is equals to, for what duration, time for which the SCR is in reverse conducting mode. Here SCR is in reverse conducting mode means here, so this duration, this is 2 pi and this is a beta. So in this duration it is in reverse blocking mode means 2 pi minus beta, and Tc equals to 2 pi minus beta by omega. This is circuit turn of time. This is 5th point and this one is the 6th point. This is regarding RL load. Now here another thing is, if you connect one diode here, so what are the, if you connect one diode across this, so what are the main advantages that we will see here. So now here single phase, this one. So now here single phase half wave control rectifier with RL freewheeling diode. So now here Vs equals to Vm sin omega t, we are applying this one. So what will happen if you connect the freewheeling diode? So freewheeling diode main advantages are here. So first one is the output voltage. Output voltage is always positive. Output voltage is positive. And next here output power increases. And next third one is here output power increases and input power factor is increases. And next here fourth point, output voltage is also is positive. Output power is increases and input power factor is increases. And next here ISRMS is not equals to I naught RMS. So for all loads in the half wave control rectifiers, so here ISRMS equals to I naught RMS, source RMS current equals to output current RMS, output RMS current. So but here only in case of RL with freewheeling diode only it is not equals. So keep it in mind. So here 4 points. And now here most important fifth one is the continuous current conduction mode is possible. So continuous current conduction mode is possible. Here this is a continuous current conduction mode is possible. So these are the most important 5 points. So first, output power is always positive. In case of RL load, so this is the negative. So now here negative voltage is, there is no negative voltage, only positive voltage, and output power is increases, input power factor is increases. And here source on IS RMS current and output I naught RMS current is not same, and continuous current conduction is possible. And now here how it will works. So now here during positive off cycle, so 0 to alpha, 0 to alpha, so SCR is in forward blocking mode, so that we have seen already. And next from alpha to pi, so SCR is conducting, so this diode is in reverse bias, means open circuit, and this is RL load. So this is from alpha to pi. From alpha, SCR acts as a short circuit. So now here this is R load and this is L load. So during this period, inductor stores the energy, some amount of energy in the form of magnetic field. So it will store some amount of energy. So after pi, so here what will happen after pi? So after pi to 2 pi, so what will happen? So this after pi to 2 pi, this is negative supply we are applying. So here the negative supply we are applying means here this is we are applying negative potential to this SCR. It acts as an open circuit and means SCR is in turn off, and this is, it will be in forward bias because here we have some amount of energy here. This energy already it has stored here. So this inductor delivers the energy from this load to this diode. So here freewheeling, the power is freewheeling diode, this one. So now here, so this one. So now here, this is the output. This voltage is 0. So this output voltage is 0 during this period. And now here thyristor voltage is up to thyristor voltage. So up to this only. So remaining duration is this one. Now here what is the output voltage formula? And now here output voltage V0 average equals to, so alpha to pi only. So now here 1 by 2 pi alpha to pi Vm sin omega t d omega t, that equals to 1 by 2 pi 1 plus cos alpha. Now here I0 average equals to 1 by, so 2 pi r 1 plus cos alpha. So now here another thing is here conduction angle. What about the conduction angle? Here for R load, for L load, and for L load and for RL load. So this is for RL load. Okay. So in case of RL load, so conduction angles are different, that we will see. So now here conduction angle of thyristor, here for this one is pi minus alpha. Conduction angle of this one is a pi minus alpha. Conduction angle of this thyristor is pi minus alpha gamma of t. And now here, and next here conduction angle of this diode. So this diode equals to, here conduction angle of diode equals to, here this here beta minus for discontinuous mode and continuous mode. So for this discontinuous mode beta minus alpha, and for this is for discontinuous, and for continuous conduction mode from pi to 2 pi plus alpha. So now here 2 pi plus alpha minus pi, that equals to pi plus alpha is the this freewheeling diode conduction angle. So now here what about the extension angle? There is no extension angle, it is a continuous conduction. This is for continuous and this is for discontinuous. So now here circuit turn off time, the time for which the SCR is in reverse bias, means here this is in reverse bias up to. So this is pi, 2 pi, and this is a pi. So 2 pi minus pi by omega Tc is equals to, and Tc equals to pi by omega. I hope all these concepts are clear to you regarding RL load and RL with freewheeling diode. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.